All right, practice 1, series number 4. This time what we're going to do is just draw our, what we see. So we have our battery here, and I'm going to draw the ammeter. Then we have resistor, resistor 2, resistor 3, even though it's a light bulb and not like the other resistors. And we have the ammeter. And then we're going to go ahead and label it. So before and after each electrical component, we're going to, aside from the ammeter, we are going to label our letters. All right, now let's go ahead and solve the problem. So the battery creates a 20-volt difference. So that means our total voltage is going to be 20 volts. Resistor 1 is 3 ohms and has a current of 3 amps. Resistor 2 has 3 voltage drop across it. So now, given all these givens, we're going to write down what we know. We know that the battery gives us a 20-volt difference. Resistor 1 has 3 ohms and draws a current of 3 amps. Resistor 2 has 3 volts voltage drop. And that's all we know. Now, I'm going to remind you that this part here means that this is the voltage drop. So the voltage drop needs to add up to our total voltage of 20 volts. All right, and we also know that it's just one of the things that we know about series is since there's only one direction for the charge to go through, that the current is going to be the same all throughout the circuit. So we know that the current of 3 amps will be going in throughout our entire circuit. Now, what does that mean for the other parts? Well, remember that as long as you have 2 out of the 3, so we have 2 right here out of the 3, we can solve for that one. So the voltage for resistor 1 is going to equal the current times the resistance. And we have a voltage 1 with a current of 3 amps times our resistance of 3 ohms. That's going to give us 9 volts. So this will be 9 volts. Now we have here, we have 2 of the 3. So we'll have voltage 2 is equal to the current of 2 times the resistance of 2. And we know 3 volts is equal to 3 amps times some resistance number. And when we divide by 3 amps on both sides, we'll get that the resistance is 1. So this is 1 ohms. And we have another one where we know 3 of the 2 values, right? So we have the total voltage is equal to the total current times the total resistance. And we have 20 volts is equal to 3 amps times the total resistance. And if we divide by 3, we will get that 20 divided by 3 is going to be 6.7 or 6.6 repeating ohms for our total resistance. All right, and now we know that 9, so right here we have our voltage, and we're going to go 20 volts is equal to 9 volts plus 3 volts plus whatever the voltage drop for 3 is. And it's going to be 20 volts is equal to 9 plus 3, which is 12. And then when we subtract, so we have 20 minus 12 will give us 8 volts for the voltage drop of resistor 3. And now we can do math this way as well. So we have 8 volts let me just write it underneath here. We have 8 volts is equal to 3 amps times resistance 3. And when we divide by 3, we should get whatever this number is should add up to 6.7. So we have 4, so it should be around 2.7 when we do our math. Okay. All right. Now we can fill in our voltage drops and our ammeters. So we have here voltage drop, or we're going to start with 0 for position A, and then position B we will have 20 volts because that is what the total volt difference is in the battery. And we'll have 20 volts, 20, 20, 20. And then we'll drop here. So for resistance 1 has a 9 volt drop, which will give us 20 minus 9 will be 11. And then nothing here, so no component, so it'll be 11 again. And after this resistor, it'll drop 3. And so this is resistor 2, has 3 voltage drop, and 3 has resistor 3 has an 8 voltage drop. Oh, sorry, this is a common mistake actually. So if it has a 3 voltage drop, we'll do 11 minus 3 will give us 8. And so then this will be 8. So 8 minus 8 will give us 0 and 0. And our ammeter reads 3 amps because whatever it is for one resistor is going to be the same in our series circuit. So now we're going to label all of the letters that we just chose. And we go up to 20. And so maybe we'll do it by 5. So 5, 10, 15, and 20. All right. And at A, we are at 0. At point B, we go up to 20. At point C, we're at 20. Point D, we go down 3, so it'll be a slight drop. E will still be, we'll go down 9, so then we'll be at 11 for D, and then we'll still be at 11 for E, and then we go down to 8 for F. We stay at 8 and then go down to 0 again. So when we draw our lines, we can see that the voltage drop is very clear. So for resistance 1, resistance 2, resistance 3. So we see that this is a 9 volt drop. We see that this is a 3 volt drop. This is an 8 volt drop, so that should all total up to our biggest number, which should be 20, which is the volt difference found in our battery.